So just from a high level, we're looking through the Meraki Mx range of products today. We'll show you some of the key features of the Mx devices, a little sort of overview of sizing options in that range. We'll then go through and look at the Sd-Wan. So Cisco obviously do Sd-Wan in two flavors. There's the Meraki and the Vptela. Today's focus is on the Meraki powered Sd-Wan. So that's the product range that Cisco acquired through Meraki purchase a number of years ago. If you do want more information on the Vptela product, so that's a sort of larger enterprise class offering, then please do get in touch and we can run a session and go through the Vptela offering as well. But as I say, today is focused around the Meraki product set. So that will be the sort of the slide deck for today. We'll be doing the live demo as I previously mentioned, and then closing out with a Q&A session. And obviously, I think Claire's already mentioned that there is a Q&A option in the WebEx event. So feel free to put your questions through there as and when you have anything, and we'll cover those off at the end. So just to run through the Meraki Mx devices. So these are as it says, the industry leading SD-WAN meeting leading edge security. So these are built with security at the core. Every Meraki device supports many features, some of those being next-gen firewall, intrusion detection and prevention. They can do content filtering. They've got a cloud brokered VPN. So by that, we mean that all devices participating in the VPN network with Meraki devices is all managed through the cloud registry for the VPN. They can also do malware protection. Every model in the range has got high availability. So you can have multiple devices fail over between the two just to keep the network up and running. So that's kind of like the overview of the products. Going into a bit more detail, as I mentioned before, they've got the high availability mode. On top of that, there are 2 WAN ports across every range. So even the smaller MX60 ranges, they come with a single WAN port, but then one of the LAN ports can be edited to become a WAN port. So every model in that range can have 2 WAN links. You've also got the LTE modem, that's built into some. The rest all support a USB connector to an LTE USB modem, so you can have failover across the 4G network. Some of the ranges also provide you with PoE options. So if you are going for the single box solution, that box can do your security, it can do your LAN switching, it can provide PoE for IP phones as well as wireless. And then as mentioned, we've got the LTE modem is built into a number of the range, and all of these support the high availability. So that's just a little overview of the range. From a sizing perspective, you can see in that range, in the photo there, the top model is the MX68. So the MX60 range are the smaller desktop mounted devices. These are great for your small office environments. And as I mentioned earlier, they're the single box solutions. Moving through the rack mounted options, we start off with MX84 and then up the range through the 100, the 250 and the 450. So these can connect up to 1,500 locations with sizable throughput as well. The other option as well is a lot of people now are looking at cloud-first strategies. So this is the VMX, so the virtual MX can be deployed in AWS and Azure. It comes in 3 sizing options. So the largest sizing option can give a gigabit of VPN throughput, with the smaller sizing doing 200 and the medium 500. So with these, if you do have a cloud-first strategy, this enables you to deploy the MX instance in the cloud, and as I mentioned, in AWS or Azure, and then interconnect all your sites from your HQ to your branch offices into the cloud, and then that's just securing all your traffic from your office locations to your cloud instances. They're great for multi-cloud strategies and for securing all that information across the internet. Another key feature of Meraki, it's zero touch. So there's a lot of IT investment in deploying solutions. So when it comes to rolling out equipment, you have to attend site, power up the device, put the initial configuration on, and it just takes a lot of time and expense because you're having to travel. With Meraki, the zero-touch provisioning, these really are true one-touch provisioning. You just literally have that equipment sent to site, plug in the network cable, which gives it access to the internet, and then it can be discovered in the cloud. So as soon as it's plugged in, added to your Meraki dashboard, the administration portal, you're able to complete all the configuration remotely. The VPN technology, it secures your branches. It's literally just 3 clicks. We will be demonstrating the addition of a site using a VPN tunnel later on, but literally like 3 clicks and you can have that branch office connected up to your HQ location, connected up to your data center in the cloud through the VMX, and you're up and running. So minimal expenditure in you can have just like local site contacts to plug these in, plug the power cable in, plug the internet circuit in, and you can then provision the site remotely. So that's the zero-touch provisioning. Overlaying the VPN technology is Sd-Wan. So Sd-Wan, it's a software-defined wide area networking. It's basically taking a software-based approach to the business to utilize and manage your network connections. So you can actually use these across Mpls, broadband, fiber optic, any DIA, direct internet access circuit, and then overlay the Sd-Wan across that circuit. So the VPN will build all the interconnectivity between each locations, and then Sd-Wan will make those routing decisions for you. So you can look to say, put all your voice across a high-grade, high-speed, reliable link, but maybe put some of your bulk traffic across a lower-cost broadband circuit that doesn't have that requirement for QoS and the issues with latency and jitter affecting voice. That's obviously why you'd need a high-grade circuit, but that bulk traffic doesn't need those high-cost links. So you can basically just say, send that across a low-cost link, but you can have the failover between the two as well. So Sd-Wan, we will be covering a session looking through there, showing you how we can make those routing decisions, make use of multiple WAN circuits, and basically give your true sort of enterprise network solution across the internet. Advanced security on these boxes, you've got your next-gen layer 7 firewalls. They can be integrated with Cisco AMP, with ThreatGrid and Cisco Umbrella. So you can actually push through the Umbrella security to your end devices. So you're essentially not just securing your network and your office environment, but also securing right down to the end user. And all this is all managed through single pane of glass as well. So not just the MX configuration, but all your switching, your wireless, should you have any cameras for security, all that will be managed through the single Meraki dashboard. So the Auto VPN, so the connectivity through Meraki, it's securely built on their site-to-site Auto VPN. A lot of challenges in the past have been around building your full meshed VPN network. There's lots of management of secure keys between devices. The way Meraki does this is through their VPN registry. So each device that's added to your organization is basically registered to the VPN registry, and then that cloud broker will then manage those connections. So you can just say you want your London office connected to your San Francisco office, connected to your Sydney office, and then once you've opted to say which site's going to be the hub, which are going to be the spoke, and which network should route through which path, then the actual Meraki cloud brokered VPN will build out all those tunnels for you. So still security at the core, but just none of that managing of all those secure keys. It's all done for you through the cloud brokered VPN. Also available in the dashboard is your monitoring. So there is real-time monitoring of that VPN. So it's taking a measurement on the latency, the jitter, the packet loss. It's taking all those into account and then giving you a MOS score, the mean opinion score. So that will basically take into account the health of that link. So when it comes to having multiple WAN links, as you have a MOS scoring against those links, you can basically say which is the higher reliable circuit, and you can actually route traffic based on that MOS scoring. So it's pretty advanced analytics. It's got supreme visibility into the key factors. You can see the scoring against all of your links in a single pane of glass. And then, yeah, obviously you can use this for troubleshooting. So if you do see a degradation in the network, one look at this screen can sometimes pinpoint you to a root cause just in a matter of seconds or minutes. So as I mentioned before, Sd-Wan is the overlay over the auto VPN, and this is what gives us the smart WAN paths. So when you've got your dual active VPN load balancing across your two links, you need to make the decisions on how you're going to route that traffic. So the methods here available, we've got PBR, the policy-based routing, and we've got the dynamic path selection. So policy-based routing is basically when you're deciding on how you'll route that traffic. So you can be measuring on the source addressing, the destination addressing, the protocol, a specific port that you want, and then you can designate, okay, so the corporate network in London, when that communicates to the corporate network in San Francisco, make a selection across the second WAN link. But when we've got a voice call going between those sites, send that across the primary WAN path. And that's when it starts saying that's based on the policy-based routing. With the dynamic path selection, you're basically using this MOS scoring. So you've got your two circuits, and then the decision there would be to say, make voice traffic use the most reliable circuit. And then Meraki Devices will basically do that analysis of the links and then route the traffic across which link is currently the best performing link. And that's where it is dynamic path selection. Again, this is all going to be demoed. It's nice and simple. You'll see the ways it can be configured, the ways it can be edited. And this performance probe it's basically just a small payload, approximately 100 bytes of UDP data. It's sent across each of the VPN tunnels every second, and then it's using that scoring in a real-time basis to make that dynamic path selection. That's probably enough around the talking for now. So what we'll do now is we'll flick into the demonstration. And as I mentioned, we'll run through the setup of VPN tunnels. We'll look at the Sd-Wan configuration and just give you an overview of some of the analytics as well available in the dashboard. So this is a cloud instance of Meraki that's been deployed. It's part of the Cisco demo network. So what we'll do is we'll just run through using this environment to sort of give you an example of some of these configurations. So initially, what we're going to just demonstrate is similar to what we said in the presentation. So we're going to look at, say, connecting London to San Francisco. And the way we do that is through the auto VPN and then the Sd-Wan overlay. So to start off with, we're going to go in through security and Sd-Wan and look at site-to-site VPN. We're in the London network at the moment, and by default, when you first open this page up, the site-to-site VPN would be off. So adding a new site in, you would see that the site is not participating in site-to-site VPN. And then you just need to make a decision as to whether it's going to be a hub or a spoke in this network. So the hub site is when it's a mesh network. So your data centers, your HQ sites, they would all be designated as hubs. And then branch sites would maybe just connect in as a spoke and connect in maybe to the data centers, the hub site. If you did have a requirement for where two branch sites have a lot of communication, then by all means, you could also make those a hub and have a mesh, a full mesh between those as well. In this example, we're just going to make London a spoke site. So we'll click to activate the spoke, and then we can add up to 3 of the hubs that we're going to communicate to. So in this example, we're going to connect to San Francisco, the HQ site, as the primary location, and then the North America and South America data centers as secondary and tertiary. We've got an option for default route. So if you're looking to secure all traffic from the branch site, you can certainly turn the default route in, and that's basically your split tunneling option. So that's saying that even internet traffic, there's no local breakout at the spokes at the branch site. All internet traffic would break out through the site that you select. So if we, in this example, we put a default route on San Francisco, then all internet traffic from our London location would break out through San Francisco. We've put the preference order in for all of those VPN connections. And then the simple next step is just to select which networks from our local London network will be routed across the links. So in this example, we've got basically saying everything apart from our guest, our IoT, and the legacy MPLS network. So the VPN's off on the final three, and it's turned on the rest. So our infrastructure, our wireless, our corp, voice, telepresence, security networks, all these networks are going to participate in the VPN and be routed across this link. And that's it. That's basically added London now as a VPN, an auto VPN connection to the 3 locations, and that'll be up and running. What we can do there is have a look at the status. So now we look at the VPN status for London, and we can see some of the performance straight away now for these 3 locations that we're connected to. We can see how much usage we've got across the links, latency, any connectivity glitches. So if there's been a breakdown in connectivity, we can see like there's a slight glitch there. You'd see some red lines in the connectivity. This is available to show you for last day, for the last week, for the last 30 days. So you can report back over to a 30-day time period. And even though it's very simple to configure, there is some brains behind this. So the VPN registry is the complex piece here. Essentially, all your MX devices make a connection to the VPN registry. As you can see here, we're connected to multiple VPN registries at present. So again, you've got failover in that setup as well. And that is the cloud brokering. So that's where we're going to get all our VPN tunnel information to ensure that the tunnels are built securely. The next thing that happens then is that any routes from our network will be learned. So now we're connected through the VPN, all the VPN tunnels are up. We'll basically learn about all our routing. So what we'll do is we'll have a quick look at the route table, and then this will give us some sort of indication as to how we're connecting to each location. Our local network here, talking to Toronto, for example, because we built it as a hub site, as a spoke site, hanging off the San Francisco hub, you can see that the next hop will go to San Francisco. So Toronto is another branch site. So all our traffic between London and Toronto is now going via San Francisco. And then what we should see is, we should see this as the secondary links as well. So we set San Francisco as the primary, the NA is the secondary. So again, you can see connections to Toronto can use through the NA data center as the secondary option, and then again through the SA data center as the third option. So you can see all the paths that have been created. All our routes have been passed from our local network now to all the other offices, and we've got connectivity. So then it's just a case of how do we actually send traffic, and what traffic do we send across these links, because we do have 2 WAN circuits connected to this office. And that's where we start looking at Sd-Wan. So if we go in through the Sd-Wan menu, we'll open up the Sd-Wan and traffic shaping, and then we'll just take a look at some of the decisions that have been configured as to how we'll route the traffic. So in the Sd-Wan page, you can actually see we've actually got the WAN circuits. So WAN 1 is our higher grade link. In this example, it's just a 10 meg per second circuit, but WAN 2 is a lower grade link, and that's just 5 megabits per second. And what we'll do is we'll just look at some of the policies that are in place. So we talked about PBR, the policy-based routing, and we talked about dynamic path selection and the way these are configured. So this example here, the third WAN policy, because this is using a traffic filter, it's basically saying anything from our .10 network, which is the corp data network to any network, that's basically saying that's a policy-based route. So if we click on this one as an example, this policy-based route, we're basically saying that any traffic, any layer 3 traffic from this VLAN, make use of WAN 2. And if we open it up, we can basically see we've not specified any other source port. We're saying that any traffic at all, anything from the corp network to any other destination network across our estate is now been set to use WAN 2. So that would be a policy-based route. If we're now looking at a dynamic path selection, we can take a look at this first example that's already been configured. So this is basically saying for SIP traffic, for our voice that's going over SIP, use the uplink that's best for VoIP traffic. And the way it's doing this is we've gone in, we've selected the expression that we want to measure, and we've selected SIP voice, and then we've selected a preferred uplink, and we basically said the best link for VoIP. So we're looking for the one with the best MOS scoring, and that would be classed as a dynamic path selection. One other configuration method is using a custom performance class. So you can see in this second example, we've got our backup traffic set to use WAN link 2, but it's using a performance class, and this performance class is called backup. And the way that works is it's looking at the latency, jitter, and maximum loss. So again, it is still a dynamic path selection. If any of these measurements should not be met, then it will automatically select the alternate link. So in this scenario, the third link would be WAN 2, but if we are seeing poor performance on WAN 2, then fail over to WAN 1. And that poor performance is measured by this custom performance class. So that's essentially how we're sort of looking at the methods of routing our traffic using the software-defined routing policies. Again, we can look at the status. So we'll go in, we'll have a look at some VPN status. And then what we're looking at here is these are our uplink decisions. So if we scroll through, let's have a look for those corporate network traffic. So we were looking at the 172.17.10 earlier, and it was set to use WAN 2. So we can see that that paths up, it's using WAN 2, and we'll have a little look at the performance on WAN 2. So now we're looking through, we can see latencies, it's not the best because it is our lower grade circuit. We're seeing a bit of jitter going on, and we are seeing some packet loss. And our MOS scoring is a rather average 1. If we want, we can look at uplink 1 to see how that's performing, or we can actually just click on all and bring up all circuits so we can get a good comparison. But in this scenario here, you're actually seeing that the WAN circuit, the primary WAN circuit is obviously a much lower latency, much lower jitter, loss, and a much better MOS scoring. So you can see straight away, when it comes to the VoIP traffic, the MOS scoring on WAN 1 is 4 times better than that on WAN 2. So straight away, your voice traffic is going to use the primary link. We are seeing a latency above 20. So that was the measurement on our backups. So our backups will actually be failing over from the WAN circuit 2 onto WAN circuit 1. But for all the other traffic, the corporate network traffic, we basically had no measurement. We just said if the source traffic is from the 172.17.10, then to use WAN 2. The only time that would fail over was if WAN 2 was down. And that's basically a quick overview of how this is all set up, how we can monitor this traffic and get the status of the links, as well as the SD-WAN configuration. So that kind of ends our demo for today. We can demo a lot more components of the Meraki range. So again, if you did want to see anything more, there is an additional license for Meraki Insight, which gives you web application health. Again, we can demonstrate that if that's something of interest, along with any of the switching, wireless, cameras. Again, that can all be demonstrated as well. But today, obviously, focusing on the SD-WAN. So what we'll do is we'll flick now back to the presentation. And following on from the demonstration, we're going to move into the Q&A section. So if you have a chance to raise any questions through the session, they'll have all been captured. And what I might do is just hand it back over to Claire, and then if you can see if there's any questions we've got raised, and we can address those as we go.
So thank you for that, David. Great presentation and great demo there. So yeah, we'll move on to some Q&A questions. We've had a few come through, so I'll just get started with our first one. We've got here, what are the benefits of moving from legacy MPLS networks to SD-WAN? And Rob, if you want to take that one.
Yeah, certainly. Picking up this one is actually at the back of I had a call with a client today who rolled out 74 locations here in Australia, big construction company. Can't name them, unfortunately, but I just made sure I did my homework for the call. So just asked the exact same thing, you know, what benefit did it give them? So apart from the usual the costs and things, the bit that they highlighted is the speed of deployment. You know, not taking into account the fact that you're putting in new hardware with better performance and better support in the Cisco world. So they were migrating, or they migrated rather, from traditional Cisco equipment into Meraki. Typically for per location or per device, it would take them 2 hours to configure a Cisco network, or a Cisco device rather. Whereas in the Meraki, in the beginning, the first maybe 5 sites with us, when we started kind of shadowing them, it took them about 30 minutes, but come site number 15 to 70, it was down to 15. So I guess from their point of view, it's more around the rapid deployment rate that they did, or they experienced. Was one of the best ones. And two benefits came at the back of that. One is obviously the time spent is a lot less, and also they did not need to, I guess, hire more people to help them push out these 74 sites rollout. So they were planning midway through to maybe bring a contractor in to assist, but it turns out that wasn't a requirement. So yeah, double savings from them on that front.
Oh, great. It's good to hear it kind of in a case study situation working there. So brilliant. Next question, we'll go to David. So this one is, what is the most common challenge you run into when deploying SD-WAN? The person asking the question has said they've been wanting to move across from their MPLS for some time, but wonder if there's any preparation that they can do to ensure a smooth transition.
Yeah, so to actually get away from MPLS, so you're going to need some sort of circuits. So what we'd always recommend is just a standard direct internet access circuit. So just get a broadband or a fiber connection delivered into the office. And that is going to be probably 99% of the lead time for the project. As Rob mentioned, the actual rollout of the Meraki can be done very quickly indeed, but the delivery of those circuits can be a challenge. So what I'd always say is, if you're planning to sort of make that transition, probably open up some requests with a few of the telcos at an early stage. See what options you've got for circuits being brought in. See if you've got your 4G connectivity options there as well. Meraki do now do a additional device, the MG range. They allow you to put your SIM card into those devices. So if you have got a device that's going to be sitting in your comms room and the 4G signal is not very good, you can actually make use of these MG devices, put that up on either exterior or up a better location with better signal, and then just wire that through your wired network back to the server room. So I'd say definitely look at your DIA circuits initially, because that probably would be the biggest stumbling block.
Okay, fantastic answer. Thank you there. And kind of running on from that, we've got a question about how long does it take to implement an SD-WAN solution? So Rob, should I direct that one to you?
Oh, that's a how long's a piece of string sort of question. As Dave mentioned, equipment delivery, typically for Meraki, they're not actually affected by all these chip issues we're having currently globally. So, the standard lead time typically is 4 to 6 weeks in terms of the hardware. So providing that the circuits are ready, you can get it up and running in weeks, really. Experience of the current client experience example that I just gave, we placed the order for the Meraki devices 4 weeks ago, and we actually got it in 2.5 weeks. So it varies. I think the key one, as Dave mentioned, is availability of client-side resource and also availability of circuit. So it could be as quick as 3 to 4 weeks.
Okay, great, thank you. And then I've got one final question for today, which is, does Cisco Anyconnect work with Meraki Mx Devices? So David, can you take that one?
Yeah, so there's been a lot of development of Anyconnect. So Anyconnect is the sort of go-to VPN client that's deployed across multiple networks. Meraki have been developing this. In their latest release, I think it's release 16 of MX, they do now include the Anyconnect software. So at present, we can connect. It's still in beta phase at the moment, but they are looking to get that rolled out as GA shortly. The way it's looking to work from a license perspective is that the Anyconnect subscription license that you have previously can basically be transferred onto the Meraki, or you can just obviously order a new Anyconnect service. But yeah, essentially it will work with Meraki. It's still getting close, but in the interim, you still have other options as well. There are other client VPN options. Systems Manager with Meraki is a good product for controlling the endpoint devices, and that can then push VPN configuration down to the end user. So nice and simple. But yes, short answer is yes, it's close.
Okay, brilliant, thank you. So that's the questions from everybody, and hopefully we've helped to kind of clarify any queries anybody had. So what I'll do now is pass over to Rob. He'll just talk through kind of the follow-ups to the session and how you can get in touch with us.
Thank you, Claire, and thank you to all the attendees. Very much appreciate your time this afternoon. From our perspective, if you have any further questions or want to book an extended demo, and in the case of some of our clients, we actually did a kind of brief proof of concept before jumping into the Sd-Wan bandwagon. Please do get in touch with either myself, Dave, or Rick. Sorry, Rick, I'm conscious you're very quiet there, but he's our backup security specialist. So, just get in touch with us, and we're more than happy to help. And looking forward to it. Thank you.
Great. Well, thank you again to everybody for joining today, and we hope you found it an engaging and insightful session. Also, thank you to our panelists. You've been brilliant. Please do get in touch if you've got any questions. We're always happy to discuss any ideas and solutions and guide you through anything we can help with. So thank you again today. Bye-bye.
Thank you. Bye-bye.
Thank you.
Bye.